Hi everyone! In today's video, we will talk about spectral indices and learn to perform them on Earth Engine. So, in remote sensing, we frequently use combinations of various bands to enhance visibility of an object so that it becomes easier to differentiate with others. The combination of two or several bands and a certain mathematical formula to feature an object is commonly called as spectral indices. In today's exercise, we will calculate NDVI, NWI, and MNDWI. So, let's begin with NDVI to calculate vegetation density in our study area. In simple terms, using a specific formula, Earth Engine calculates pixels of same value to generate a specific feature, like vegetation, water, or soil in an image. It means all other features will be eliminated, and only specific index like vegetation, water, or soil will be shown in the output image. Most popular spectral indices are NDVI, which is Normalized Difference Vegetation Index, Normalized Difference Water Index, NDWI, Enhanced Vegetation Index, EVI, which is also related to vegetation, Normalized Difference Snow Index, NDSI, Normalized Burnt Ratio Index, NBRI, and Bare Soil Index, BSI. NDVI is the normalized difference of the red and the infrared band, calculated as NDVI equals to near infrared band subtracted from red band and divided on near infrared plus red band. Let us try to apply this formula to a Sentinel-2 scene. Keep in mind that in order to calculate the NDVI in the Google Earth Engine, we will need to work with images, not image collections. In this example, we will access the whole Sentinel-2 Level 2A collection for August 2022 and mosaic it to create a single image so that we can cover maximum study area. After extracting mosaic image, clip it to your study area like this. This is all the pre-processing to calculate spectral indices. Now, to calculate vegetative index, you have to find the correct band suited into the formula for NDVI. In our case, for Sentinel-2, near infrared and red band is B8 and B4. Google Earth Engine offers 3 ways to calculate the NDVI from your image. Here, we will have a look at one basic method. I will add other 2 into class homework. The first method uses simple band operations integrated in the Earth Engine to calculate band math. It means simply defining formula. Introduce 2 new variables to select bands from the clipped image, like NIR and red, and select band 8 for NIR and band 4 for red, like this. Now, introduce a new variable, NDVI2, and type this formula like near infrared, subtract, red band, and then divide. After that, dot near infrared. Add red band. It is the same formula written in Java language. Use dot rename to rename your result as NDVI. To display NDVI on map, define visual parameters. Now, the parameters will change to palette because we are not working on image. We are displaying calculated pixels into the map. For this, minimum value will be -1 for all non-vegetative pixels, and maximum value will be 1 for all pixels with dense vegetation. The colors are the default for features. Add it to the map and hit Run. As you can see, we have NDVI for our study area. You can change the colors to this palette for better visualization of image. Take a pause and read the comments before using this palette, and then hit Run. Here, we have a deep NDVI visualization. By zooming in, you can see the dense vegetation areas here and there. Okay, now let us calculate NWI, Normalized Water Index, using another simple method to calculate spectral indices. You can calculate it by previous method. You just have to change the band range according to water index formula. Simply add the dot normalized difference and in the brackets add green and near infrared bands, which are B3 and B8 for Sentinel-2, to calculate water index. It is the simplest and quickest method to calculate spectral indices. Now simply add it to the map by defining colors. Hit Run. Here we have NWI for our study area. Zoom in and explore. You can also calculate MNWI and other indices. I will leave them for class homework. Thanks for watching.